Okay, now we're continuing with exercise 5.6. We want to solve the following graphically. Absolute value of 3x minus 1 equals x plus 3. So to do this, we're going to sketch y equals absolute value of 3x minus 1, and we're going to sketch the graph of y equals x plus 3, and we're going to see where the points of intersection are. Now, we're not going to be able to read the points of intersection off the graph. We are going to have to still do some algebraic solving, okay? So 1, 2, 3. I'm just going to put 1, 2, 3. Okay. Now, the first graph, y equals absolute value of 3x minus 1. This is a V-shaped graph. Your V-shaped absolute value function shifted to the right. So putting 3x minus 1 equals 0, shifted to the right by 1/3. So it has an x-intercept of 1/3, and let's just have a look at the y-intercept for y equals absolute value of 3x minus 1. When x is 0, y is absolute value of -1, which is 1. So I'm going to sketch that here. So 1/3 would be roughly there. And let's just pick another point. So I'll just put it down here. So I'm just going when x is 0, y is 1. When x is 1/3, I've got y is 0. And I'm just going to do when x is 1. When x is 1, y is 2. So just sketching a few points. Now, the reason I've done this is quite a steep curve. So before you sketch, you'll notice that when you look at y equals 3x minus 1, the gradient of the line is 3. So it's got to be, you have to draw these a lot steeper than the graph y equals x plus 3, which only has a gradient of 1. So that is why I've just redrawn that. It was clearly drawn before, but not steep enough. Okay? So now I need to, so this is the sketch of y equals absolute value of 3x minus 1. We now want to sketch y equals x plus 3. So just plotting some points. When x is 0, y is 3. It's got a positive gradient. It's going to go like that. I'm going to just do when x is -3. What's y? When x is -3, what's y? 0. Okay. So y equals x plus 3 has a gradient of 1, cuts the y-intercept is 3. It would go like that. So just drawing that. Quick sketch. Now, all right, if you look at, we can see there's a point of intersection there, but there is going to be a point of intersection up here somewhere. So my second point of intersection is up there. Are we okay? I mean, I can continue that, but, your second point of intersection is up there somewhere. So to find the points of intersection, which equations do I solve? So there's number 1, and number 2 point of intersection is up here somewhere, okay? So what is the graph of this line here? Remember, this is the function y equals absolute value of 3x minus 1. What is the equation of this line? Y equals 3x plus minus 1. And the other equation is, the equation of this other line is -3x plus 1. Okay? So now we are actually going to solve algebraically after all. Okay? So what this is asking is, what is the intersection of, where are the points of intersection of the graphs y equals absolute value of 3x minus 1 and y equals x plus 3? We've got, one of them will be roughly around -1 and the other one's probably up at 5 or something like that, or 4. Okay? All right. So to find point of intersection 1, which graphs do I solve simultaneously? This one? Are we okay with this? So I put -3x plus 1, or it's the negative of that. Are we okay with that? Remember, this is the negative of, so it's negative bracket 3x minus 1, which is -3x plus 1, equals x plus 3. So it gives me the point of intersection of those two lines. I'll just do the x plus 3 if you want in another colour. Yes, who are you looking for? Oh, graph of y equals x plus 3 is in red. Okay? So solving this, what have we got? We've got, be careful, 4x equals -2. Did you get x is -2 on 4, which is -1/2, is one solution. And the other solution up here, we're solving the equations 3x minus 1 equals x plus 3. So we've got 2x equals 3 plus 1 is 4, x is 2. Yeah, my graph's not very good. I said it was going to be 4 or 5. It's 2. So much for, you know, my graph's not drawn very well. Okay? Bad drawing. Okay? The next question, solve the following graphically. So in the end, we did solve it algebraically anyway. Did you see that we actually did? So you'll only solve graphically if they ask you to, all right? So absolute value of 2x plus 1 equals 1 minus x. Just going to try and put some sort of scale. Okay, 3, 2, 1. Okay. So let's draw the graphs. You can do them in 2 different colors if you want, and then solve. Okay, the absolute value function has been shifted where? To the left or to the right? So what makes 2x plus 1 equals 0? X is negative a half. So it's been shifted to the left, negative a half. Negative a half. What makes 2x plus 1 equal to 0? Negative 1 divided by 2. What's the y-intercept of the function y equals absolute value of 2x plus 1? When x is 0, y is 1. Looks like this. Let's do when x is negative 1. What's y? When x is negative 1, negative 2 plus 1 is negative 1. Absolute value of negative 1 is 1. Girls, if it was an absolute value, it would have been down here at negative 1. So when you're drawing an absolute value function, see I've got this dotted line down here. That is where the function would have been. However, it bounces back off the x-axis. So y equals 2x plus 1 is this whole line down here, but the absolute value, the negative values get, instead of negative 1, absolute value of negative 1 is positive 1. Instead of getting negative 2, absolute value of negative 2 is positive 2. The graph gets reflected back up. Only for sideways shifts. If it's an up and down shift, the graph will go above or below. Okay, so that's y equals absolute value of 2x plus 1. And then we've got the graph, if we want to sketch y equals 1 minus x, that's got a negative gradient. Y-intercept is 1. This one would have to be here. When x is 1, y is 0. So this graph looks like this. Now, whenever you've got the 2 lines with the different gradients, they will meet. Okay, when you've got lines with the same gradient, they never meet. You know, parallel lines never meet. But 2 lines with different gradients will meet somewhere. Okay? All right, so we've got 2 points of intersection. We've got this point here. It does look like the point 0, 1. Okay? And there's the second point of intersection. Okay? So, it does look like x is 0 is a solution, but let's just solve. So, what is the equation of this first line? The positive gradient. With the absolute value function, we're writing out the 2 equations. Y equals 2x plus 1, and this other one over here is y equals the negative. It's negative 2x minus 1. And now to find the points of intersection. We can already see that x is 0 is the point of intersection of the first one, but I'm just going to solve it anyway. So 2x plus 1 equals 1 minus x, and we get x equals 0. And for point of intersection 2, negative 2x minus 1, which is negative bracket 2x plus 1, but we've expanded already, equals 1 minus x. And so we get negative 2x plus x equals 1 plus 1. Just be careful you don't mess up here. Negative x is 2, so x is negative 2. So your solutions are x is negative 2 and 0. Okay? We're also going to solve, you know how we know the points of intersection are negative 2 and 0? You could be also asked the following question. To solve absolute value of 2x plus 1 is less than or equal to 1 minus x, or I could ask you to solve absolute value of 2x plus 1 is greater than, let's say, 1 minus x. So if you were asked to solve, so in this question we've been asked to solve absolute value of 2x plus 1 equals 1 minus x. If you're asked to solve this with an inequality, you still solve it the same way and put equal to x, and then this is just asking me, because this is where we started, finished off yesterday, which graph needs to be above which graph to solve this inequality. What this is asking me is where is the absolute value function below the function 1 minus x. Do you see that? So looking at your graph, where is the absolute value function, which is the black one, below the straight line graph? Where does that occur, girls? For which x values? I know the points of intersection are 0 and -2. So where does this inequality hold? Can you see what this is asking you? I need the absolute value function to be below the line 1 minus x. Isn't this where it's below? So which x values hold there? Because when we're solving this, they're asking me to solve for x. What are the x values? -2 through to 0. So the solution to that is -2 is less than x is less than or equal to 0. Sorry, less than or equal to x is less than or equal to 0. So if you put in the value x is -1 into the absolute value function, you'll get a lower y value than you would if you put it into the 1 minus x. See, it's saying where is the absolute function less than, which means below the line. And if I asked you the other way around, where is the absolute function value function greater than or above the straight line graph? Can you see this is what it's asking you? Where? Here, and it's above there as well. So your solution there is x is less than -2, x is greater than 0. Do we see that? Do we understand that that's what it's saying? Where is the absolute function higher up than the straight line graph? And you look at your graph, and this is the absolute value function. It's above the straight line graph and over here as well. So you are solving for x. So you give me the x values for where this occurs. Okay? All right. So if you're asked to solve this, you need to put equals 0 first and then solve the inequality.